Hi, welkom bij de DevSecOps Road Trip hier in Nederland. Mijn naam is Brian Vermeer en ik ben een developer advocate bij Snyk. En ik ben hier samen met mijn co-host Matt Jarvis. Ik spreek vloeiend Nederlands, dat is het probleem niet. But because we have more people than Dutch people on this trip, and probably people from overseas, we will continue in English. First of all, I want to welcome...
Shame, Brian. I'd prepared my opening statements in Dutch, but...
Okay, go ahead. Go ahead. You've got 5 seconds.
I couldn't
Let's
now.
go.
I couldn't now. It's not fair on
fair point. But I appreciate it that you did that. First of all, I want to have a big shout out to our community sponsor for today, which is Cloud Native Amsterdam. At the end of we basically have 2 talks. At the end of it, we will come back with Q&A and we will represent Cloud Native Amsterdam and ask somebody like Alessandro will probably join us to what's going on in the community and how Cloud Native Amsterdam is doing and what they're up to nowadays. But first, we have 2 speakers today. And the first speaker for the first session is Nanne Baars. He is a developer at Xebia. And he is also one of the project lead, or he is the project lead for the OWASP WebGoat project. So that will be interesting. We will be starting off. And I will do the second talk. Well, let's not talk about that. You can zoom out afterwards. That's all okay. Just stay for Nanne's talk because that is the interesting one today. But before we get into talks, Matt, where are you currently? I mean, that looks very Dutch. Absolutely.
This is everywhere in the Netherlands, isn't it, Brian? Tulips and windmills everywhere.
Yeah, what I already said is everywhere where we send tourists. That is absolutely true. If you're a tourist in the Netherlands, you probably see flowers and windmills because that's what you expect. I am based in Breda, which is one of the cities in the southern part of the Netherlands, and I'm actually based there. So this is my hometown. I see that that Sam is currently based in Amsterdam, that must be Amsterdam. I mean,
I'm virtually in Amsterdam.
Virtually in Amsterdam, which is cool. I mean, Amsterdam is a good place to be there as a tourist. Sorry for everybody who's based in Amsterdam, but every day we have this challenge, Matt and I. We ask each other questions about the country that we are currently. First day was the UK, and Matt asked me 5 questions about the UK, which I only had 2 correct. Yesterday we were in France and we asked each other 3 questions, and now it's my turn to ask Matt 5 questions about the Netherlands. So Matt, are you ready?
Yes, I'm frightened, but I'm ready. Let's go.
All right. The first one is an easy one. I think it's an easy one. In which city in the Netherlands is the parliament situated? You're awfully quiet.
I'm thinking Utrecht.
No, unfortunately, it's The Hague. Like everything that has something to do with the government. The majority of the ministries are in The Hague. That is the central.
I really should have got that.
Okay, second one. You can get this one. This one is not that difficult. What is the most famous picture of our famous Dutch master Rembrandt van Rijn, and is displayed in the Rijksmuseum in Amsterdam? What is the name of that picture?
Is that the girl with the pearl earring?
Come on. The girl with the pearl earring is from Vermeer, which is basically... Yeah. So I will give you another guess.
No.
It is, we in Holland call it the Nachtwacht or the Night Watch, which is one of the biggest paintings that he made. It's currently restored into its original form, and it's basically the main attraction of the Rijksmuseum in Amsterdam.
I wouldn't have known that. I'm sorry. Brian.
Okay. You have been in the Netherlands before, right?
Yes, I have.
Okay, can you tell me what a bitterbal is?
Is it a food stuff?
It is a foodstuff, but I want to know more because food is very, very general. It is.
Is it like is it like a donut?
No, I will give you another chance.
No.
A bitterbal is a deep fried snack within the Netherlands. You know, It's basically, if you're based in Holland, you know what a croquette or a croquette is. Like it's a crunchy thing, but a bitterbal is a ball-formed crunchy snack, deep fried, and most of the time there's meat inside it. And we eat it with basically everything, but most of the times it's a very, very delightful pub snack. So you eat it with mustard.
I knew it was deep fried something, but
it's a deep fried ball with meat in it. And well, the fun thing is I went into Amsterdam the other day and there were tourists wanted to have that as their main course. It was like, nobody does that, but hey, good, fine by me. It is delicious. Okay, I will give you a question with options. You know that in the Netherlands, we bike everywhere, right? You see a bike here on the other side here, you see a bicycle. So we bike everywhere. How many bicycles are there in the Netherlands? And I will give you a few options. It's a lot. It's that, first of all, we are here with about 17 million people. So how many bikes are there? Is that 12 million? So less than one per person? Is that about 17 million? So one per person? Is that 22 million, like 1.3 per person? 34 million, which basically is 2 for each person? Or is it 40 million over 2?
I'm going to say it's 40 million.
That is unfortunately not true. Although there are a lot of people who have more than one bikes. The average is it's 22 million bikes. It's 1.3 bike per.
I knew it was more than one per person.
It is more than one per person. Yeah. We are the country with the most bikes per square meter. And that's what it is. Okay. Last one. Listen carefully. By law, how much cannabis are you allowed to have with you in the Netherlands? Is that 10 grams? Is that 5 grams? Or is that 0 grams? So by law, how much cannabis, and that can either be weed or hashish, are you allowed to have with you by law?
I think I'm going to say it's 0 grams.
And that is absolutely correct. Because
there's some weird thing about the law about
exactly. Some people will be like, but you're yes, because people are like, but you're allowed to have cannabis. No, we have something in the Netherlands we call gedoogbeleid, which is basically a tolerancy policy. By law, you're not allowed to have any with you, but because we're tolerant people, we say like less than 5 grams, we do not prosecute, we do not do anything with it unless you are annoying. Then they probably ask you to a police officer can ask you to hand it in. However, if it's above 5 grams, you will get an actual fine. With under 5 grams, you will not get fined, you will not get prosecuted, nothing is going on. But by law, it is not allowed. And that's weird in the Netherlands because we have laws you can't just ignore. There are laws and you can say, it's okay to ignore them. So by law, nothing.
I have to apologize to everybody I know in the Netherlands because, you know, that to get 0 apart from the question about cannabis just feels wrong somehow.
But it is true. And people think it's legal here. By law, it's not. Only we tolerate it and it's okay. Let's go ahead. So that were my 5 questions to you, Matt. And you have exactly 1 correct.
Yay, I didn't get 0. That's
you didn't get a 0. So let's move on. Tomorrow we've got Germany, and I have to look up some interesting facts. However, let's continue to our first speaker, which is Nanne. And Nanne, if you would be so kind to share your screen, please. Nanne will talk about where we'll start his talk. I will give this virtual stage to you, Nanne. So go ahead, and we see you back in about 20-25 minutes. Cheers.
Okay. Thank you. So thanks for the invitation for giving a presentation. And today I want to focus on from the attack and go back to what do we need to know as a developer about certain kinds of attack. So a little bit about me. I'm Nanne. I'm from the Netherlands. I'm a developer at Xebia, which is a consultancy company in the Netherlands. And like mentioned before, I'm one of the project leads of the WebGoat project. A little bit about the WebGoat project. It's a vulnerable web application maintained by OWASP, and it's designed to teach everybody about web application security lessons. So in each lesson, we start with a small introduction about the vulnerability. We give you some assignments to complete. And then in the end, we end up with a write-up on how you can mitigate that specific vulnerability inside your own application. It's open source. You can download it and you can start it. And yeah, so please try it out. So today we are going to talk, and I'm going to talk about an attack called XML external entity attack. And I want to do that from the point of a developer. Sorry, I need to. So really so the attack is pretty simple. We will see in a few minutes what the attack is especially about. But I think it's very interesting to see how we as developers need to work our way around to make our XML parsing secure, especially in Java. The same holds for different programming language, but in Java it's a little bit more complicated because we have a lot of XML parsers going around. So these are the kind of things I'm hearing when I talk to other developers. So people say this is no longer an issue since Java 8. We will look into this because it is still an issue. People say it's easy to protect. I beg to differ. It's difficult to protect you. It's not that difficult, but you need to know exactly what you are doing in order to protect yourself. Some developers even say, XML external entity attack. What is it? Because I never heard of it. And of course, people, the favorite thing I'm hearing all of, there are no severe consequences attached to this attack, because an SQL injection, everybody knows, well, you have data in your database, and if you have an SQL injection, you can exfiltrate data from the database. People know that works in that way, and that's why with this attack, people think there are no real severe consequences. We will look into that and see why this is also not the case. So what is it? So let's first start with a definition. An XXE attack is an attack against an application that processes XML as input. And the attack occurs when the XML input contains a reference to an external entity, and that one is processed by the XML parser. So let's first look at the how that's normally being done in XML. So this is an XML document. The first part is called the document type definition. In the document type definition, you can specify the structure of your XML message. So in this case, it defines the author tag as an element, which contains of simple data. And we also define an entity called JS, which is a constant, which has a constant value called Joe Smith in this case. And you can see in the last line that we reference that entity inside the author tag. So what happens when the XML parser parses this XML document? The parser encounters the entity called JS. It will look up the entity inside the document type definition, and it will replace the entity reference with the value attached to it. So in this case, the author tag will be expanded into Joe Smith. This is very helpful in XML documents that you can do this, because you can think about, you only need to define your name once. And in the whole XML document, you can reference to this entity, and the XML parser will do all the work. So if you want to change the value of Joe Smith, you can do that in one place, and the whole document reflects this change immediately. So where can this go wrong if you are using an insecure XML parser is in this case. So in this case, we have the same XML document. I created a different entity here. It's called show me. And it is reading a file from the file system. So if the XML parser is parsing this document, it will see the entity reference. It looks up the entity reference, show me, and show me is meant to read a file from the file system. In this case, password A, because that's the easy thing to do. Because with this simple example, you can, for example, a pen tester will probably give you this as evidence, because it's reading a file from the file system, which you are not supposed to read. It's not the most, and then as you can see, the parser inserts the complete file within the author tag of the XML structure. And if that's reflected back to the user can see what kind of users are present on that system. So this is the case where it is not that great to have the ability to declare an external entity in a document type definition. This is another example, which is called the billion laughs. And if you look at the last line, you will see what is happening here. There's a reference to lol9, and lol9 reference to the other one, lol8, and etc., etc., etc. And if the XML parser is parsing this document, it will consume a lot of memory, and it will probably crash your server immediately with sending one message. In the recent Java versions, there is some protection against it. So the level of nesting is limited to a certain threshold. So this might or might not work anymore, depending on what kind of XML parser you are using. So what are the consequences of being able to pull off an XXE attack? Well, as we've seen before, we can read confidential data from the file system. And because we also have the option to list directories, we can even see if there are some files. So we can brute force and see if some directories contain some files we are expecting. So if you know the technology the server is running on, you could, for example, read config files, which the config files might contain database passwords, for example, and you might be able to exfiltrate that data through an XXE attack. So we have seen the denial of service is a problem. Sending one message might crash your server. And sometimes the XXE is also used for a stepping stone for a server-side request forgery, because the application is running on your server. It is prone to an XXE attack, and then you are able from that server to go into the back office of your system, connect to other servers. So that way you can pivot into the system and pull off a server-side request for you. You can also use it for port scanning. You can also scan for IP addresses, so you can get the range. And then if you know that information, you can leverage your attack in that way, and maybe try to directly connect to other hosts in that way. So why is it still an issue? And if you look at this line defines a simple XML parser for reading an XML document into a document object model. And I'm asking myself this question because XXE has been around since, I think, 2002. That's the early reference I could find of this kind of attack. And we are still writing this code. And why is this still giving you an insecure parser? It's insecure by default, so you have to do work to make it secure. And I think that one of the things in Java which is very important, is backwards compatibility, because if they change if they would have changed it and created a secure parser, libraries might start breaking and there's no backwards compatibility. But on the other hand, they could have thought about a way to define new instance as the safe parser and create an extra method like unsafe instance, so they can know what you're actually doing. But still, it's not the case, and we are still prone to insecure parsers. So when you use an XML parser inside your code as a developer, you need to think about, is this secure? Is it secure by default? Is this parser accepting XML messages from the outside world? If not, maybe it's not that important to protect it. But since we know we copy and paste a lot of code as developers, and this might end up in a piece in the code where you are actually reading XML messages from the outside world. So then again, you are prone to the XXE attack. Luckily, there are some static code analysis tools which enable you to find these kind of constructs, and they will warn you about that you're not doing the correct way. You're not instantiating the parser in the correct way. You're missing a few properties, and they will find those instances. So I think the same as with the next SQL injection, XXE, it will be with us for a very, very long time. And I think we will never solve this issue without breaking and making sure that every runtime, XML runtime actually gives you a secure parser. Before we think that we can solve the issue with static code analysis, you have to be aware that looking at this piece of code, it might not be obvious, but this static basic parser pool is part of the SAML library. It's not really important to know what it does, but it actually instantiates an XML parser inside the library. So what this means is that the static code analysis tool is probably not as smart that it can look into the jar files and see that you're instantiating a static parser, basic parser pool, because that one instantiates an XML parser. So the correct way to do it is to parse a map of properties, features in this case, and that will be passed on to the XML parser. So you are using it in a high, so the library is the high level construct you're using in your application. The library is creating the XML parser, and the XML parser is has to be secured. Otherwise, you are again prone to the attack. So as developers, we are using a lot of external libraries to build our projects. Luckily, a lot of people are looking at those libraries. If the library contains a vulnerability, a CVE is created, severity is assigned to the CVE, and then a new version of that library is how do you call it, released, and we hopefully integrate it in our project. So looking at this one is from Spring integration. It was prone to the XXE attack, and then what happened is that because you're using Spring integration, when receiving XML so you're not actually instantiating your own parser, you're just using the library, but the library is vulnerable for an XXE attack, so you have to update that library. Luckily, there are some tools like the OWASP dependency check, and of course, Snyk also has their own framework to detect that you're using vulnerable libraries inside your code. One thing I do see, it's more common nowadays to have that as part of your CI/CD pipeline, to have one of those scanners running. But on the other hand, what I do see is that when a project is in active development, each and every time the project is built, dependency check or the Snyk tooling will run. But once a project has been delivered in production, make sure that you're still checking it on a regular basis. So do a build of your main branch every now and then, so like once a day or maybe once a week, to find out if the code running in production is actually vulnerable, uses a vulnerable library. And that sometimes people forget about this step because the project is no longer actively developed, the pipelines won't run as often anymore, and you forget about it. But using libraries also gives some mixed messages. So this one is, I'm not, but this is an interesting one from Jackson. Jackson is a well-known framework for parsing JSON and XML into plain Java objects. And in 2016, it was vulnerable for an XXE attack, which got fixed. There was a ticket on GitHub. And the title of the ticket is that ensure defaults for XML input factory have expansions of external parsed general entities disabled, which is interesting because that's actually saying that by default is disabled, so we get a secure parser. And even there was another one for the support of the document type definitions that they should be disabled unless explicitly overwritten. So I thought that's cool because that means that Jackson by default, if you're using the correct version, so the version after it, I think it was 2.7 or something, that we have a secure parser. We don't need to worry anymore about these kind of attacks. But using the correct library, what can possibly go wrong, you would say? Well, it turns out that it's not as nice and as how do you call it? The sun isn't shining in this case, because if you write a Spring Boot application, which is a popular framework in the Java world, and when you create some APIs for REST or for passing in XML, you need to be able to consume those XML messages. So if you do that, we probably know that Spring already has an object mapper by default, but when you want to parse XML, it's something different because it's not JSON, it's XML. So you probably, the first guess is to Google on Stack Overflow, for example, and say, oh, I want to use an XML mapper. How do I configure that on a Spring? And Stack Overflow, as Stack Overflow is good at, it gives you an example of how to configure an XML mapper in as a bean. The funny part is that the object mapper created by Spring is already capable of parsing XML as long as you have the Jackson libraries for XML on your class path. So Spring, you don't even need to define an XML mapper explicitly. the object mapper is capable of doing both. So it can parse JSON and it can parse XML. XML mapper is a subclass of object mapper. The funny thing is, and that's why my interest got where my interest was raised, is that Spring does it in a little bit of a different way, because we just saw that Jackson fixed a vulnerability and they made it secure by default. It was disabled by default. But it turns out that's not the case, and I was interested and triggered by this one because Spring actually does almost the same thing, but it passes along two properties to the input factory. And I thought, okay, maybe that's just because it's Spring and they want to be extra secure, so they do the right thing. They create an XML parser, they explicitly set those properties, so that's probably why they do it. It turns out that if we look a little bit deeper inside the code, so here we have the same construct we copied from Stack Overflow. The XML mapper is part of the Spring framework, and we call this constructor in the XML mapper class. And that one creates a new XML factory. That XML factory is part of the Jackson library. And if we follow that XML input factory, it goes into this constructor. This constructor calls the other constructor again of the XML factory class. And then something interesting happens, because what it does is, if XML in is null, it creates a new instance, and then it applies those properties for preventing the XXE attack. But we are not doing that. We are passing in our own XML input factory .new instance. So it's not null. So we don't get the protection we were hoping for. So that's why, yeah, I find it a little bit like, this is not common, I hope, in programming, that if you pass in nothing, that you get a parser which is actually secure. If you pass in something yourself, it's not actually applying those secure properties which you said you would in the GitHub issue. So yeah, I think this, if you do something and you are playing around with constructors and passing null and stuff like that, you can better explicitly give it a name, that you are actually creating an unsafe parser if you are specifying an XML input factory, and that the user, the developer, is aware that he needs to make sure that the input factory gets those properties set. So where did this go wrong? And I reread the issue again on GitHub, and it turns out that it only works like this: if the parser, the XML input factory, is actually instantiated by Jackson. If it's not instantiated by Jackson, you're off on your own, and you have to fix it yourself. So that's why Spring is actually doing the right thing and passing along those. This is the construct from Jackson, but as we've seen before, Spring is actually setting those properties explicitly. So the other thing we as Java developers have to be very worried about, not worried about, is the pluggability. It's on one hand it's a blessing, on the other hand it is kind of like, why do we have so many choices? So in Java you have an XML specification, and people can build their own XML library based on the specification. If you adhere to the specification, your library can be used inside, and it can be you can exchange those parsers at runtime, so that you can use a different parser, which is good because that gives us the opportunity to move to a better parser if one is available, which might be quicker. But on the other hand, it also complicates things a little bit, because it's now all dependent on the runtime. So in Java, OpenJDK 1.8 had a JAX-Bay runtime provided for you, which actually used the secure configuration. But if you use the IBM Java Virtual Machine 1.8, it was not secure by default. So I think that's where the mistake began, that it all depends on the runtime. And after Java 11, it's no longer, the runtime is no longer part of the OpenJDK, for example, and you have to provide it yourself or get to a transitive dependency, which makes it even more difficult to find out which parser library you're actually using down the line. So to give you a little bit context around this issue is that I've worked on a project a couple of years ago. It was Java 8, which was very modern for those times. And we used a Wildfly application. So it was an old school Java AA application, which message-driven beans, which consumes XML messages and processes and we process those messages inside our system. And I knew about this vulnerability, so I added a simple unit test to test that our parser was safe by default. Everything okay, tests were green, was running in the CI pipeline, so nothing to worry about. But then on the other hand, we deployed to production using a Docker container, and we had the same Wildfly instance. And then just before we went to production, we had a pen test, and well, an hour into the pen test, the pen tester comes to our desk and says, well, I think I found a critical vulnerability inside your application. I said, okay, what's the vulnerability? So I said, he found an XXE vulnerability. I said, well, that's not possible because we actually have a test for that. I said, well, we can give you the evidence, you can see for yourself. And it turns out that we actually had that vulnerability. And it turns out that the Docker image we used for Wildfly pulled in another JBoss image, which was dependent on another image. And that image depended on something even more strange, and that one pulled in an XML runtime, which was not giving us a parser which was safe by default. That's why we were vulnerable for this kind of attack. So it worked fine on Java 8 with the unit test, but it didn't work out on the Docker container. So it's important to test both sides. So if you have it in your local CI, but also make sure that you test it on your real target environment, that it still works. So let's see a little bit about it. So let me think about, yes. So is JAX-B safe or not? Well, it kind of depends. And this is how JAX-B works in, so this is how you parse an XML message into a person object. So here we use a JAX-B parser, we create your marshaller, it reads the document, it creates the Java object, and we print out the person.getName. We use an XXE attack, we read that file from the file system, and it turns out this doesn't work because we are not allowed to do that because we have a safe parser. So that works out fine. So we are protected, that's good. But what if we use a different method? And this is where it gets a little bit strange and nasty, I would say, is that the JAX-B parser has a lot of overloaded unmarshal methods. And one of the methods allows you to override the default parser JAX-B is using. So what you can do is you can plug in any SAX2 compliant parser and use that one to parse the XML document. So let's do that. We change the code a little bit. We have to create a source, which is a SAX source, and which uses a parser. And the JAX-B code almost stays the same. Only the unmarshal method uses now the XML source, which is tied to a different XML parser. And now if you print out the name, you get this. So you get the name, John in this case, and you actually get the contents of that password file into your person.getName. So why is this the case? And that's where it becomes a little bit strange, is that we now have an extra parser on top of it, which is not by default safe. JAX-B is using that parser, so that's why JAX-B is now also vulnerable to an XXE attack. So we need to protect both, and this is how you do it. There's also a little bit, it's also difficult as developers to know, you probably know when you define a parser, which parser you're using, but which properties to set is very difficult. So here you see 3 examples, and you see that you need to, one is setting a property, one is setting an attribute, one is setting a feature, and those string literals is something you need to really know about in the context of your current XML parser. So passing, and the most horrible thing is, if you pass a property, it's put in the map, and most parsers will just read the map and say, okay, this property, I don't know what it's about, but I will just skip it and not give an error. So people are using the wrong properties to protect the parser because they found something which they can copy, they put it in, and it doesn't work because it's not the right property to use for that XML runtime. So we can skip this one. So the mitigations. So the default reaction when creating an XML parser should always be apply the correct settings. There's a nice OWASP cheat sheet where you can see all the different XML, the popular XML libraries, which are currently used in the Java ecosystem. And for each and every one of them, they specified what you need to do. So check your libraries. If you're using a library, make sure you're using the correct configuration. Be aware that sometimes you need to pass in, like we've seen with the basic parser pool, that you need to pass in extra information to when creating those objects. Yeah, write test to validate, but also test on your target system. Now apply the tools for static code analysis. They will help, and they will find the most simple cases. They will trigger an alert, and you will be aware that you need to do some work in this area. And of course, check for vulnerable libraries. And I hope there will be some day where we, as Java developers, gets a helper method like this. So a library, for example, which actually just gives you a default parser. So you say create secure SAX parser factory, and you just get a parser which is saved by default. You don't need to worry about it anymore. And that whole new instance thing just gets removed from the JDK. And you can only choose between creating a secure parser or overriding it with some super complicated flag to make it possible to create an unsecure parser. I think that's the good way, and that's the best way, and not the other way around, by default insecure, and you have to do work to make it secure. That's, in my opinion, the incorrect way. So if you want to read something more about how this all works in Java, is look at the XML concept feature secure processing, and that's really, it was added through the Java process, and the explanation is that it does secure you by default for the denial of service attack, so the billion laughs. That is the one it's actually protecting. But in the specification, there's also like, okay, but if you set it explicitly on the parser, you should also make it the parser secure against an XXE attack, which is kind of weird because the specification is doing something by default, but there's an exception if you explicitly set it on the and then that's where it all goes wrong. And I like, it's just horrible how that whole specification is written. It's not the problem that the specification is incorrect, but the library developers are just following that specification, and they move all the responsibility towards the developers. So the library developers say, hey, you have that feature flag, use it. But then you, as developer, you have to exactly know in which case you need to do what to enable that secure parser. If you want to know and want to try out a little bit more, this is the WebGoat we talked about in the beginning. And we have, of course, an XXE lesson as well, where we explain the attack, and you can do one yourself and see how it works. And the funny part is, it looks very simple, but if you want to do more complex stuff, it becomes really difficult to get all the XML things correct. So the last lesson is one example where you need to be very aware of what you need to do before you can pull off this XXE attack. It's not a common attack. It's easy to protect against, but as an attacker, to get the whole thing working is more difficult than you would expect. So that's I hopefully give you a little bit of a background in how we as developers, you think you are working with an XML parser, and it's very difficult to secure you against these kind of attacks. So thanks for your attention, and I think we go back to.
Thank you very much. That was awesome. Super interesting. I know we're tight on time at the minute, so folks, we'll move questions over into the chat if you wouldn't mind, and we'll move straight on because I have to do the next intro. You may know him as the co-host of the DevSecOps European Road Trip, but he's also a Java champion, software engineer, a community leader, and he's also a expert in Taekwondo, so I have to say nice things about him. So our next speaker is my friend Brian Vermeer. Over to you, Brian.
All right, thank you. Don't be afraid. There's distance between us. I mean, you're on the other side of the sea. So
yeah, for now, that's true. But speaking about distance, let me get you into a story that happened to me basically a few months ago. I went on vacation, which is pretty awesome during COVID times. But if you go into the airport nowadays, you have to do a bunch of stuff. Like, you used to just have your passport, you scan it, you walk through, might even look like if you're within the EU, it's all super easy. But now you had to do like QR codes for if you are vaccinated. You have to make sure that there are tests explicitly for the location that you are, that you have a location form for where you're going, where you're from, etc. So you need to do a bunch of stuff nowadays just to get on an airplane and get somewhere else. That reminded me of the fact that people try to implement DevOps. I mean,
DevOps, first it was like, as a developer, I created my application, I just threw it over the wall, and the operations folks just took care of that, which was brilliant. However, now we need to take care of it our own as a team, operations and developers together, and we need to make sure that it's running. And if I create it, I need to own it. And if something goes wrong, then the whole team is responsible. That's about DevOps. However, with DevOps, we look at features, like, is it working how it's supposed to be working? Is it scalable, maintainable? Is the code readable? But one thing we're forgetting in this is the security part. That's why we put this in the middle, and it's important. But is it? Well, you already had a brief introduction about me. This is me, community, some stuff with Java. But let's go into what the actual problems are. So, and yes, so say 10 years ago, I worked for a government agency in the Netherlands, and we deployed our application 3 times a year. At that point, we had enough time to hire a pen tester, do the pen testing, all the stuff, and make sure that we are absolutely safe before going into production. Nowadays, if you look at e-commerce websites, for instance, or see the Facebooks and the Spotifys of this world, we might need to deploy like 3 times a day. So we are speeding up these kind of things. However, developers think about developing, operations folks think about operational things, and security comes back at the end. There is basically a lack of focus on security because, hey, I didn't get it back in university. Did you? So we need to have more focus all out of the life cycle, not just at the end of the road, or, hey, I created my application 3 weeks in the sprint, and then at the end there is this security team, which is still siloed like we had with developers and operations, and then they come back with me with a whole list of defects like, this is going wrong. You know how that makes me feel? Emotional. No, there's getting tension between developers and the security folks, because it's always about what went wrong. But in the end, we need to make sure that our customers' data is safe, right? We're on the same team. So this is not something that is a very good way of working. So let's get into the problem a bit more. And I will use a Java example as well, but it's not only Java, but it's easy for me to do it in Java. If you're working in Java, you probably know this. This is the Spring Boot initializer, and it scaffolds an application for you. You can pick and choose what kind of dependencies you want, and it already creates a full-blown application for you, so you can run it from the start. It doesn't do anything, but it runs. I know that within the Node.js community, there are also scaffolding applications that can already do a bunch of the plumbing for you. Absolutely amazing. But then we have this. I have a main method that starts up my application. Great. And now I'm talking about only the code that we write. Something is scaffold, but it's still in my face. I know what it is. I know what I'm doing. So I start building my first endpoint. Something like this. I just make an endpoint to hello, and this is what I'm doing. Do you already see what the problem is over here? There's kind of a security issue with this code, isn't there? Let me enlarge it quickly, like doing my, it works. So the point is, I'm having a request parameter, user, and I directly write it back to the response. Typically type 1 XSS, cross-site scripting issue. Put in something like this, and you will get where I'm going. And this is probably pretty easy to spot if you do code reviews. This is a very, very easy textbook example. But this is not the only way how to do it. You also can do it with mouse overs, images, and all that kind of stuff. Still the same application. However, do you spot it while you are developing? When you are doing code reviews, do you actually care about these kind of things? Tell me honestly, do you? Well, say we have an application. And I basically have the same issue over here in this application. We can insert tooling, of course, that can help you. And of course, my tooling that I'm using, and I'm using my own tooling, but it's about that we can use the tooling right away inside your IDE so I can fix it right away. It says to me there's a cross-site scripting issue. Now let me enlarge it. It says something about, hey, there is a user controller on line 35, and on line 38, you write it right away. This is an example how you can solve it. Okay. That is pretty useful, because just saying something is wrong, go fetch, is not helping me as a developer. That just gives me more problems because my manager is pushing towards me like, we need to get this stuff out. You remember? 3 times a day. So this one is probably easy to spot. But what about things like this one? This one is a path reversal created when you upload a file. And if my file name that I use here, and I reuse that file name, but what if my file name is something like this? I go all the way outside of my application into the barebone server and put it somewhere. Well, again, helping you with tooling that gives you right away from help you right away from the start already gives you that advantage, and not just doing it in your CI pipeline or further down the road, that I can solve it right away. Just like with your unit test, make sure that you can do it quick. You do it quick and early. So having tools that help you out, and over here they say something like, hey, maybe we should use the canonical path and check that, which makes sense. But that is your code, right? And there is over here, that's the tip of the iceberg. That is basically 10 to 20% of your code. And it's not something only, your application, that's not just your code. I mean, underneath the surface of this iceberg, there is a lot more. Oh, I showed you the tooling. There's a lot more. First of all, the open source dependencies or your libraries. Nanne already talked about this, but this is generally, this is 80 to 90% of your code base. You just inherit that. And how do you take care of that? Did you just pull it in because your Stack Overflow post told you that, hey, just get this library and it works? It might work, but what are the consequences of that? Because if you bring in a framework such as Spring Boot or whatever framework, I'm not bashing on Spring Boot specifically, but be aware that a library brings in, or a framework brings in libraries, and that goes several layers deep. And deep down below, there can be a application or there can be a library that might have a vulnerability that you didn't know of. And that's what we need to take care of, because it's not just your code. And we take good care of that code with code reviews. I get it. But say this is my application, that only REST controller. That is not the whole binary. This is the whole binary. And the rest of the binaries are basically stuff I included from using my package manager, either Maven or NPM or Yarn or PyPI, but I inherited. How do you take care of that? How do you pick the dependency? Did you ever look at who is maintaining the dependency, if it's still maintained, if there are problems with it, and how do you take care of that over time? So, oh, wait, on my screen, something is happening, so I don't see but how bad is that situation? Well, let me take you back into 2017, and you probably heard of this, so I will go through that quick. 2017, company in the United States, Equifax. I'm not going into the company. Company is not important. The hack is important. They were building their business logic, their own code on top of Apache Struts 2. But because of that, all the plumbing and all the stuff that you don't want to use as a developer, don't want to do as a developer, was already done for you, which is a good sign, because I don't want to create yet another corrupt repository or yet another endpoint. No, I would just do the stuff that they hire me for. However, what happened is they were using an outdated version of that Apache Struts library. And in the end, over 140 million customers were compromised. Just give you a little timeline. March 7, 2017, there was already this vulnerability was already disclosed, and there was a key security patch available. May 12th, that's basically 2 months later, the breach started. So you get where I'm going? They didn't look at what's in production anymore, just like Nanne told us in the previous talk. But it took over 70 days, 76 days to be in total, that it was discovered by the company that somebody was actually in. They could get in, they could snoop around. Over 140 million customers were compromised. And at this point, with all the lawsuits, over $2 billion does it cost so far. But that's not counting in all the damage it does to your reputation. If you work for Equifax right now, you probably work at one of the most secure companies, because they did a bunch to reverse it. So props to them. But let's go into that hack that makes that then you can actually show that it's actually not something that is on the mind of the developer. So I have an application over here, and that application runs on Heroku. It starts up right now because, hey, it's in the background, so it needs to be started. But I don't need to go into the application because it's not the code that I wrote. No. Let's go like a real hacker into a terminal. And what we do is we can use a header to do a curl request towards this application, because it uses that vulnerable struts library. And this header is just a content type. This is the value of that content type. And it's a pretty weird one. It is a invalid content type. And by using this invalid content type with a specific version of Apache struts, you go into an exceptional flow. In that exceptional flow, you can, for some reason, you could use the expression language OGNL within struts. With that expression language, I can call certain methods, I can create new objects. And that's what I'm doing here. I'm creating a process builder, which spins up a new process. I feed this process the bash, and I feed this bash an arbitrary command. Then I reroute the input stream to an output stream to show it to you. So let's just do this. So I'm using this header, and now I am substituting the word command for the word env. And basically that's your Linux command to show you the environment variables. And I'm pointing it at my Java Groove Brian at .heroku.com. Let's see if it's online already. Yes, it's there. Amazing. So if I just call this one, you will see that in the response, my output stream gives me the environment variables. And although this might crash, or it might not be fully into the buffer, but it means that on the server side, the execution of the env command did take place. And if I can call in the env command, I can create files, I can create scripts, I can go back tomorrow morning and execute that script. Good luck with you finding out what happened. And that is because I wasn't aware that I was using something that was vulnerable and not in a way that I have tested it. And we might have caught this when using a pen tester, but that takes days, and I don't have days because we need to push it out. Again, we're focusing on features, not so much security. So one of the things you can do is scan your application for that. We already talked about your code, but hey, I connected my GitHub repo, for instance, to our tooling. And again, there's more tooling than my tooling, but of course I'm using my own tooling. One thing I did was I looked into this application and I saw that there were problems like the Apache struts 2 problem, and it's a critical problem. And by just removing the version I'm using or update it to a newer, minor version, I would have got rid of all the things. It shows me what the actual problem is, not into a specific mindset, but like what we can do and how to remediate it. And that is the key point. Just saying, hey, this is wrong, go fetch, again, is not helpful, but helping you in a way that you can do this right from the start, like either connecting your GitHub repo, or do it on your local machine. You can do it as well. But you get me. You need to take care of more than just your code. All right. So open source usage has exploded over the last couple of years, well, last decade, basically. But remember that the use of open source is free, but also not for free, because it comes with responsibility. It's not secure nor more insecure than your code. It's just like your code. People create it, people make mistakes, stuff gets found, but you need to update it in a certain manner. You need to be aware that if something happens, or if you're using something, that you take responsibility for it, and not just because, hey, it works, never touch it again. Because if you're using open source and a package that is well known and well used by many, many developers, then you get into the point that, hey, if there is a problem, like in the Apache struts example, then there might be a lot of people that using that. So I just create a script, put it on every single endpoint on the internet I can find, and maybe I get lucky. And that is, in a nutshell, what happened to Equifax. They were not specifically targeted. It was a coincidence. So new packages created in every ecosystem per year. And you see that the spike is with NPM. So there are a lot of packages within NPM, and I'm not making fun of NPM. I normally do, but not today. There are a lot of packages in NPM that do the same. So how do you pick the right one? That's up to you. Do you have a policy for that? Do you are aware of what you're picking? Or, hey, it works, ship it. Even though for other ecosystems it's less, there are still new packages every year. So we need to keep tuning this. We need to be aware of this. Because already told you that the vulnerabilities are not so much for the larger ecosystems in the direct vulnerabilities. No, they're most of the time in what comes with it. So you inherit something, you put something in your package.json or your POM file, and implicitly you download 20 other packages. Did you know? Are you aware? And how do you take care of that in the future? Because software is not anymore creating it. We're in a DevOps age, so we need to take care of that when things go wrong. when we ask developers on things like, hey, or when we ask people, and it all comes from our state of open source security research and our report, like who needs to be, who is basically responsible for security? Then we can see that it differs, but developers need to take their fair share. So as early as possible in our, we'll say, life cycle, we need to make fair choices. And that's for both your code, but also for your infrastructure. Think about it. As a developer, you make the choice how to solve a certain thing with what kind of parser, if we're talking about XXE parsers like Nanne did, or what kind of package you bring in. So both your code and the dependencies you use, you make a conscious choice how to solve it because it's maintainable, it's speedy, but is it secure? That is one of the things we should take into consideration while we pick it. But then we come to infrastructure. It's also a thing like there's more than code nowadays. And we see that if we look over the whole landscape, that we need to take, it's a shared responsibility between developers, security team, and operations. Hey, fortunately, that means DevSecOps. But again, we need to take our fair share also in the infrastructure, because next stop underneath the water, there are our containers. Nowadays, you don't just push a binary anymore. No, it needs to go into a container, either virtually like within Heroku, it's basically packed into an image, or you do Docker containers or containers with Podman or whatever cloud solution you're using. But some people still tend to believe that if you're using a container, because of there is a layer of abstraction, by default, we are much safer. And that is not true. Unfortunately, it's the other way around. So let's focus a little bit on Docker containers, like the happy whale. In 2019, I did a research on Docker containers, and I pulled the 10 most commonly used Docker images from Docker Hub and scanned them for vulnerabilities. Because the first thing that you do normally is, hey, from Ubuntu or from Node or from whatever, you base it on somebody else's image. So I did this and I looked over it, and we saw that if I just pulled the latest image, all of these images had vulnerabilities in their operating system layer mainly. So it's not, if I took the Node latest one, it was based upon a full-blown Debian ecosystem or the Debian operating system. Pretty much not what you want for a small microservice, do you? So think about it. What kind of image do I use? Maybe I can use a smaller image, or maybe I can scan that image because everything that comes with that image is also maybe a point of attack. So I can go over this, like how do you find out about operating system vulnerabilities and how do you get deployed it? But I want to show you a last breach. So let's go into an application. Well, you saw that Java application I showed you before, right? That to-do application, and I managed to package it into into a Docker file or into a Docker image. Unfortunately, the CSS doesn't work. But the point is, I'm not targeting the Java application. I'm targeting the container. And this is basically what I'm targeting. I am targeting a problem in Apache Tomcat that I'm using. And with it, it was possible to upload the JSP file to the server via a specially crafted request. And this JSP could be requested, and any code it contains can be executed. So if I go over here to the exploit database, you see it over here. I already opened it for you. We see that this script already does this for me. It's out there in the open, and that's the whole point. If somebody knows, they might publish it. So what this does, it creates the application, or it uses the Python script to do the request, and it has two payloads. The first payload is to test, and it just creates a JSP file with a print line to see if it works, gives you all sorts of A's. And the second one is actually inserting a form, and that form you can put in words, and that words will be put into a runtime. That means that if I put in a word that is a command, I can execute it. So just to show you that my POC.jsp is not yet there, but I already prepared this again in another container over here. Now let's see if this works. I put Python over here so you can look it up later. And if I do is, it will check. and it says like, hey, poc.jsp is now right here. So let's refresh this thing I had over here, and we see that poc.jsp is there. That means I can execute because Tomcat has this vulnerability. The next one, I'm going to use pwn.jsp, which is basically that form I showed you. Let's insert that. So doing that right away, let's try it, uploading web shell. So now I didn't touch the application. No, I now have a web shell. So I'll say something like, who am I? And I'm root because in general, that's how a Docker container runs if you don't put any specific user in it. Or I can see what kind of packages are there. I basically have a web shell available for me. And we could have found out if you either scan your stuff or you are aware of what kind of image you're using. I scanned it here again with Snyk. And for instance, it says like the base image you're using is Tomcat 8.5.21, Java runtime 8. But if I update to 8.5.41, that will be solved. Again, it is actionable results that I want. So let me finish the application up. I just need 5 minutes more of your time. I will be quick, I promise. So we did the hacking part. The last part of your thing is your infrastructure as code. I don't have a actual hack for that, but you can imagine that it's not just one container. You need to orchestrate your containers in such a way that you have 2 instances of that application, 1 instance of a database, maybe an instance of a cache. And you can do a lot of things wrong over there that also is, well, makes every container run as root, for instance. It's not something that you want. So again, your application code, your open source code, your containers, but also your infrastructure as code is something that we as developers need to deliver, and it's something that can be attacked. But how to solve this? You can solve this. You need to solve 3 things. I showed you tooling, but tooling is not the option, not the complete option. Culture, process, and tooling. And let's look at culture first. We work with different people, developers, operations people, and security and managers, for instance, and we all have different KPIs. As a developer, I want to create stuff. I want to use new frameworks. I want to build stuff. However, if we look at security folks, they want to make sure that we're not getting breached. But if we're sitting in our cubicle and not talking to each other, we only get friction, what I told you at the beginning of this presentation. And if we only focus on what's going wrong and we need to be fully aware of whatever, maybe just have a nice chat with a coffee to say like, okay, what is the problem? And then the developer says, I'm under so much stress because my manager is pushing on me because we need to get this feature out right now. And I don't know how to work with it. Hey, then we got an angle how we can solve this. We can help developers, and we might need to speak to the management and to C-level as well to say like, features out is fine, but if you don't give developers enough time to get rid of their, well, say that technical debt, it's a problem that will start to rise and it will get worse and worse. So we need to have a culture that we care about each other's KPIs. Also, process. Don't put in a process that say like in your CI pipeline, now we have a gate, and if this gate is not fully green, we're not going to production. You know what the first thing is I would do? Let's see how I can circumvent that gate to make sure that it looks green and it goes to production. Because hey, I still have my KPIs, make sure that it's out fast. But if we make sure that we have stuff in place that basically assists us in our current process, then we are one step ahead. Still make sure that the teams are autonomous. Still make sure that the teams are aware of what they still can choose whatever they want, but enable them with the right. And there you got it. Tooling. Tooling is not something like you need to know how to use a tool. You need to know what you're looking for. You need to know how to use it, and you need to implement it in the right way that it helps your team. Just saying, do it like this doesn't work because every team works differently. Normally, if you look at a software development lifecycle, we would say in a practical situation, try to do it in every step of that software development lifecycle. While you're coding on your local machine, connect your GitHub repository to it. It may be a CI pipeline. I'm not a fan of breaking a CI pipeline, to be fair, but that's my personal opinion. But once you're done, you're not done. Why not take a snapshot of that point in time and monitor whatever is there? Because if I put it into production, I know what image I use in my Docker. I know what kind of libraries I'm using because that's static. I know what code is there, so I can just scan it and get actively pinged if something is wrong or there is a new solution for that, because what's safe now can be unsafe tomorrow. And then you hear a lot of these security folks talking about shift left. But where is the left in a continuous process? There is no left. That means that everybody needs to be in, everybody needs to make sure that we are aware of these things and that the right tooling is there, that throughout the whole life cycle, we are aware of that and that we engage and empower the development team or the DevOps team to be security from the start so we can catch things early and hopefully often. That's about it. Thank you so much.
Awesome. Thank you, Brian. Great talk. So I guess we're over time now, so we probably need to wrap up for today. So thank you to all our friends from the Netherlands for joining us. Tomorrow, it's exactly the same time slot. We will be in Germany, right?
Absolutely.
Excellent.
Yes.
So thank you.
Germany,
Thank you for joining us,
two
folks.
awesome speakers. Again, thank you to Cloud Native Amsterdam for supporting us. It looks like Alessandro couldn't make it today, but we'll send some details about what they're up to. And everyone have a great day.
All right. Thank you so much. See you tomorrow. And thank you, Nanne, for your great
Thanks,
speech.
Nanne.
Yeah, you're welcome. Dank je.
Bye, everyone.
Bye.